I think if we go back to the beginning of my career, I've been mostly a full stack web developer. Well, I actually started learning QBasic. That was my introduction to the world of programming. High-level programming languages generally spoil us a little bit. They do so much for us and we stop thinking about all the basic optimizations. There needs to be such a huge benefit that dismisses every other opposition in the conversation. And this is something you never do in Python or JavaScript. It's maybe a very simple example.
Hi everyone, and welcome to a new episode of the Rust Interview series. Today I'm going to be your host. My name is Luca Palmieri and I'm the author of Zero to Production Rust. Today, here with me, we have Luciano Mammino. Luciano is a senior architect experienced in the world of cloud-native development. In particular, we're going to tap into his expertise regarding serverless and Lambda computed, as it relates to the Rust programming language. Hi, Luciano.
Hi, Luca. It's a pleasure to be here.
Thank you for coming. So, before we get into the nitty-gritty details, would you mind introducing yourself to our listeners?
Yeah, I think you did a great job introducing me. So what I can add on top of that is that I am the author of the book Node.js Design Patterns. So that tells a little bit about my experience with other programming languages, I guess. And then I work for a company called Fortiorem. We are a consulting company, AWS partner. So we work in the cloud space, helping our customers to be successful with AWS.
I see. So what's your background in terms of technologies? Obviously, we mentioned the cloud, AWS, serverless. What's your expertise in terms of like programming languages and tools that you routinely use?
Yeah, I think if we go back to the beginning of my career, I think I've been mostly a full stack web developer for the majority of my career. And I've been using a bunch of different languages. I actually started learning QBasic. That was my introduction to the world of programming. But then more professionally, I used PHP for a number of years, JavaScript, and then Node.js, trying to build full stack applications, all with JavaScript as much as I could. But in between, I had a chance to use all sorts of different programming languages, a little bit of .NET, Ruby, even Lua more recently. So I think generally speaking, I've been using mostly high-level programming languages, which is maybe going to be an interesting segue when we start to talk about my experience with Rust. And I think it's also relevant to mention that in the last probably 6 to 7 years, I was always doing my role as a full stack web developer for the most part, but I was involved more and more in cloud projects, mostly in AWS. And because I was working in teams that were highly dynamic, where everyone was trying to contribute end to end, I was more and more exposed to how do we build applications for the cloud, how do we test them, how do we release them, how do we make them scalable. So that kind of led me to transition more and more to a role where I am officially an architect and doing more and more of like cloud architecture, but it's still a bit of a hybrid role where I get to do also lots of coding and help to build and ship things to production.
Yeah, because I mean, in the end, you're always a full stack developer, right? And when I say full stack, I usually mean in the FAT definition of the stack, which is front end, back end, but also the infrastructure layer. Like for example, myself, I am a full stack backend developer. Like I don't do the front end, but I do a lot of infra and I do a lot of backend code. And I think you always need at least a little bit of awareness of what's like above and below to do the job you want to do at a certain point in the stack well. So you said you're a polyglot, basically. You've touched all the generational programming languages that people of our age have like kind of gone through, PHP and all the likes. And as you said, they're all high level or at least dynamic programming languages. What piqued your interest in Rust specifically?
Yeah, I think if we have to go a little bit back on what sparkled the interest in more, I would say, low-level programming languages, was when I was working on actually something related to Lambda. So I was working on this pipeline where at some point we realized that one of the steps, which was a Lambda, was particularly slow and was effectively slowing down the processing of data that we wanted to be processed as much real time as possible. So we were indexing networking metadata and make it available for search in the case of incidents in the company and people wanted to investigate what went wrong. Maybe there was an attack in the network and people wanted to investigate. So basically we were ingesting all this metadata and make it searchable. And part of this ingestion pipeline was effectively a bottleneck, and it was Lambda written in JavaScript. And the reason why it was slow, it wasn't necessarily because of Lambda or JavaScript itself, it's just because it was using a specific protocol for encoding the data called cap and proto. And the library for JavaScript wasn't particularly efficient. So initially, what I did, I was trying to rewrite it entirely in JavaScript, like actually properly implementing the protocol and not just deserializing everything all the time, which was the actual issue with the library. And that took me a long time. I think I worked like 3 weeks, and then I realized I implemented only like 20% of the protocol. And that's where I realized, well, maybe if I start to look into other languages, I can see if there is a better library for them. And then I was bumping into the implementation in Go and in Rust. And eventually, for that particular use case, I ended up using Go because it looked so much simpler to just get started with Go. The library was very clear, and I was able to get everything done, I think, in a week, which was amazing for me to be able to be so productive in such a short amount of time. And then I basically delivered that project. There were a few interesting things, like in production at some point we had few null pointer exceptions, which I didn't expect from a language like Go. So something else maybe we might talk about later on. But I was amazed on how much more performant it was. And the compromise wasn't like learning a language that would take me forever to learn, or having to do extremely like low level things and be worried about extremely low level details. So I think that was the moment where I started to be more curious about, okay, maybe the new languages today, which are still low level languages, are not as complex as C. You don't have to spend like years learning them before you can ship something to production. So that was kind of the trigger for me to get curious. And then after I had this experience with Go, I wanted to compare with Rust, which I think is the language that generally people talk about when they want to pick one of the modern languages that is a little bit more low level. And I found Rust a little bit more challenging, but maybe that was the reason why I was even more curious to learn it, because like, okay, everyone is so passionate about Rust, but it's also a little bit tricky to learn. So there must be something there where at some point you unlock certain trade-offs that make the language, learning the language and knowing the language very valuable for projects that you might be building in a company, in the cloud, or for side projects.
Yeah, I see. So there's two type of people. This has a little bit of friction, so I'm gonna just work harder because that makes it interesting. And then there's a little bit of friction. I don't know if it's worth my time. I'm just gonna bounce back. So you're type A. How was the learning process? So you were coming from high level dynamic languages, as you mentioned. You had done a little bit of Go, which is really more like an high level language than it is like Rust in many different ways. And Rust brings to the table a bunch of different concepts, right? Like there's memory management, that's borrow checking, which is related to memory management. There's a very different type system, very functional in many ways. How did that go when you tried to approach the language? How do you find it?
Yeah, I'm not gonna hide that initially was a little bit tough. Like I started by trying to do two different projects. The first one was a project that I already built in the past in JavaScript, which is effectively a brute force thing that allows you to crack JWT tokens. So if you have a JWT token signed with a symmetric key, then you can effectively try all the possible combinations until you figure out, okay, this key actually matches the signature. So that basically tells you, okay, now you can generate your own JWT tokens for this particular system. And yeah, it's a project is relatively successful, the one I built in JavaScript, but of course it's not the most efficient. And when you do brute forcing, of course, you want to be as efficient as you can because you want to try as many attempts as possible per second. So I thought, okay, I'm going to try to rewrite this in Rust. And actually, I never completed that project, but eventually that project became a command line tool to inspect the content of JWT. So it's still very useful, and I'm still really happy I built it. But that was like the first project that I tried to build. And I remember at the very beginning, I was trying to do simple things like for loops. And then I would bump into issues like, oh, you cannot reference this variable anymore because it was moved. And I was like, what? What does that mean? I mean, I can do this in any other language I know, and it's not a problem. Why is here a problem? So that's where I started to realize that there were some fundamental concepts in Rust that you needed to learn and appreciate why those concepts were there before you could actually be productive with the language, before you could actually even do simpler things. And I think there was a little bit of friction there, because on one side it was frustrating that you couldn't do the simplest things. On the other side, you start to question, well, there must be a good reason why the language is preventing me from doing a certain things in a certain way. And then I think that's when, if you actually spend the time to deep dive into, okay, let me try to find out what are the reason, then you also start to learn about concepts like memory management and why the language was built in a certain way to try to prevent certain common mistakes when we talk about memory and safety and all the kind of stuff that Rust tries to prevent. And I think at that point it was, again, just a little bit of friction, but also just a little bit of curiosity to really understand, okay, why I didn't see this concept before. And then you start to appreciate that in higher level programming languages, there is a runtime that takes care of all of that stuff for you. But the compromise is that then you don't really have fine grained control of what you want to do. And that generally means slightly worse performance. So I think I really enjoyed at some point to having to learn all these details and to be able to use Rust, because it's something that, of course, I studied at the university, but then it's one of those things that you just put on the side and you never have to deal with. And therefore, you kind of move on and you forget all this good stuff that is still happening behind the scenes.
Yeah, it's kind of like Rust brings you solutions to a problem you don't have if you're coming from a high level programming language, because like, I have all these straitjacket constraints and which are there to prevent dangers that I've not seen in a while. And that's a reaction I've got a lot from folks coming specifically from Python, Ruby, and JavaScript. And are like, I mean, there's no problem with thread safety. We don't have threads. Like, what about thread safety? It's fine. It's a solved problem. Or yeah, in the case of Python, you have the global interpreter log. So there's a lot of like raw power that brings, critical dangers that you don't necessarily are able to harness in a dynamic programming language, means you're not exposed to the problems associated with those kind of challenges. And so my question to you would be, obviously you spend a lot of time like rediscovering in a certain sense low-level programming, the concepts associated with it, and then the way Rust systematizes those. Have you had a chance to actually deploy Rust on a project which was production like? So you mentioned the CLI and a bunch of local experiments. Did you manage to take it to some kind of commercial system?
Yeah, I would probably answer mainly no. And the reason why I say mainly is because I actually have a bunch of side projects written in Rust that you could probably consider, if you stretch it a little bit, production, because they are deployed somewhere. But it's not really like there is a company behind them making money. So you really need to make sure you follow all the best practices. So probably the answer is more of a no than a yes, but I have shipped something to some kind of production, let's put it this way. And this is mainly libraries. I have a few libraries that I built, very small things, and mostly as an exercise for myself. But actually, apparently, there are some people using some of these libraries, like the CLI tool I mentioned. And another one is a very simple web application written using Axum, which is kind of a game where you see different kinds of pictures and you have to guess the category for that particular picture. And then you are offered like 10 random pictures over the course of a game session. And then at the end, you get a score, and there is like a ranking that lasts like a few months, and people can be notified of whoever is the winner. So it's relatively simple application, but I think there is enough complexity there to have a feeling for what it will take to build a web application in Rust, containerize it, and then ship it to some kind of a production environment.
I see. And considering all the effort you have to pour through, right? So new language, new concepts, a bunch of new tooling as well. But then you are not immediately seeing, a benefit in your day-to-day, I guess, development practices. Would you recommend the same investment to someone else who's used to high-level programming languages? Like, does it make sense to learn Rust and invest time into Rust, even if you don't get a chance to use it at work, fundamentally?
In general, I would say yes, but of course, I recognize that different people might have different interests. I think generally I'm very curious and I like to have a broad knowledge. So if there is a new shiny thing, probably I'm attracted to at least explore it superficially to try to understand why the thing is there and maybe can ever be useful to me in the future. So if you have the same attitude, I would definitely recommend learning Rust, at least a little bit, just to see what brings to the table. Maybe you're not going to use it today, tomorrow, but maybe in 2 or 3 years' time, you will have a good use case where you realize, well, Rust is actually a perfect fit for this use case. So maybe now I'm going to put a little bit more effort into learning it and making sure I can actually take advantage of what it brings to the table. So in general, I would say that even if you don't do all of that because you see a production use case, what I found out with myself is that even when I'm writing Python or JavaScript, because Rust kind of brought back lots of things that I have forgotten from the university time, I think the style of programming, even when you use high-level programming languages, changes a little bit. You question a little bit more. Am I just copying memory all the time without realizing? And is this maybe something that is affecting performance? Can I just change this small thing to avoid memory copy and make the program, even if it's an high-level programming language, a little bit faster than it would be without really thinking about all these kind of problems? And I think high-level programming languages generally spoil us a little bit because they do so much for us and we stop thinking about all the basic optimizations. Another thing is, for instance, I really like in Rust the result type and the optional type. And this is, for instance, when you use the serde JSON crate and you use the raw value type, it really forces you to really, every single field you want to access, to really make sure that field exists, that is the correct type. And this is something you never do in Python or JavaScript. It's maybe a very simple example, but now every time I'm processing JSON data in Python or JavaScript, I always think, well, what if this field doesn't even exist in the structure that I'm getting? What if it's not, I don't know, a string? Maybe it's a number, and maybe I'm trying to do a string operation in the next line. So I think it's just forcing me to think a little bit harder about all the edge cases, just because in the Rust programming language, the types that you get, try to make sure that you use all the information you have correct and you just don't make assumptions that might not be true 100% of the time. So I think that there is value just in learning a little bit of Rust to acquire that kind of mindset. Then you can go back to your own preferred high-level programming language and use it. And I think you will be a little bit of a better programmer just because of this kind of experience.
No, no, yeah, I've had the same experience when I started learning Rust. This was like 6 years ago, and I was coming from Python, so similarly, high-level language. And even some concepts like ownership, you kind of bring back to you in such a way that you structure your programs and like make very explicit blocks. It's like, okay, this is needed here, this is needed here. And even though you don't have scopes and you don't have, moving values from owner to owner, you still see that your code kind of becomes more Rust-like in the structure. Obviously, you can take it too far. In the same way that you can write Java like Rust, you can also write Rust like Python, which is not idiomatic and doesn't work for a variety of ways. But I guess that's true for any programming language. Like, if the same reason why people sometimes suggest, go learn a functional programming language, because that's gonna teach you some patterns. It's gonna teach you some things. And even if you never use Haskell again, some of those things will stay with you in whatever language you want to take. And then you take it too far and you write functional programming extensions for your languages. That's different. Let's exit the programming language topic slightly. Let's go back to your professional interests. So you mentioned you've been doing a lot of cloud architecture, and in particular, you've been doing serverless computing. For those among the listeners who have not had the pleasure, to spend some time with the serverless primitives and just in general with the world of serverless architecture, what is serverless? Why should we care?
Yeah, I think serverless is one of the biggest misnomers of the history of computer science, I guess. And the reason why is because, if you think about the name, it means kind of no servers, but of course there are servers somewhere because you are running some kind of code, some kind of application. So there needs to be an entity somewhere running that code. So I guess the way that you can read this name is not that there are no servers, it's more that you as a developer or as somebody bringing something to production don't really have to be so concerned about what kind of server, when does it get updated, how big it is. You have different units that allows you to abstract more that part of the problem. So you focus a little bit more on the business logic, you focus a little bit more on the code. And to be fair, this is just one of the aspects of serverless that the proper definition is still a little bit debated in the community. There isn't really an official one. but one that I really like also puts a lot of emphasis on the way that serverless application run is scaled to zero. So when the system is not doing anything, maybe there is no user or there is no activity, it should be able to scale down to zero. And as a consumer of cloud products, you should be able to pay zero if nothing is happening. And that means that, of course, when something is happening, you pay on a consumption-based model, which, depending on the service, might be a little bit different. But if we talk about function as a service, that generally is you have some kind of unit cost, and then you multiply that unit cost for the amount of time that your code is actually running. So if I have to summarize all of that, serverless is a way to build applications in the cloud that abstracts a lot more the infrastructure for you, so you can focus more on the code, and also gives you this ability to effectively only use the underlying infrastructure when something interesting is happening, and therefore paying only when you are actually doing something, and not just paying because maybe you allocated a virtual machine somewhere and you happen to use it only 1% of the time.
No. Yeah, another way to look at it, and this was from my past experience, is that serverless architectures are very good if you want to attach an infrastructure cost to each operation inside your product, which serverful, if you want to use that name, applications do not do, right? Like if you have a machine running somewhere that's handling all the routes for a certain API, that machine is going to cost you a certain amount of money based on how big it is and how long it runs. But it's very difficult to say how much does the slash pay endpoint cost me in infrastructure, because it's all kind of bundled together with the rest of the API. It's using the same servers, perhaps it's using the same database. If you explode that in a serverless architecture where everything is like pay per usage and it scales to zero, then you can just aggregate everything that it's on, the slash pay Lambda invocation downstream. And, the make a payment costs you 0.07 cents, let's say, per payment, which sounds like, does it really matter? But, once you scale to a certain size and you start to care about profitability and unit costs of, the services you do offer, this is quite attracting. So like there's a finance angle to serverless as well, like finance engineering, so to say.
A very, very good point. And I think on the same line, you might also argue that you can do more fine-grained security because, of course, you can attach more restrictive policies to specific lambdas. So, for instance, if the slash pay endpoint should be able to access only a specific database and nothing else, then you can actually limit that. Or maybe you can make other things read-only, other parts of your application read-only if they don't need to write data. And of course, this is something that you can probably do in serverful applications, but it will be a lot more code that you write to constrained access rather than having policies that you can attach directly to the compute level. So that's definitely another aspect that serverless brings to the table. And similarly, you can also think about structuring teams, because since the unit is much smaller in general, then it's easier for different teams to figure out, okay, what can we work on, and make sure that you have teams that are more focused and they don't step into each other's toes because maybe they don't have conflicting deployments or all that kind of stuff.
No, that is true. I guess the counter alter to that is that you end up doing a lot more infrastructure, because a lot more of the logic ends up living in like the glue between the pieces of code rather than in the code. And that may be a pro or a con depending on your skill sets, what you like to do, and so on and so forth. We talked about serverless before, we talked about Rust. Let's look at the combination, right? Like, what's the serverless story at the moment if you're trying to use Rust? Like, how painful it is to actually write a serverless Rust function.
Yeah, before giving you a straight answer to that, I think it's a good point to remark that I think that serverless plus Rust, I believe, is actually one of the sweet spots to introduce Rust in an organization. And if we go back to the point where we said you generally pay for a unit of price and time, the unit of price, at least in the case of AWS Lambda, is how much memory are you allocating for a specific Lambda function. And then the faster you can execute, of course, the cheaper it's going to be. So if you think about Rust, and if you think, okay, I'm going to be writing a Lambda in Rust, generally speaking, something written in Rust can be very efficient in terms of memory allocation. So you can try to reduce that allocation of memory as much as you can, and that reduces your unit price. And the other element is, well, Rust is generally pretty efficient. So maybe the same task written in Rust can be completed much faster. So you're also reducing the time that it takes for that particular Lambda function to execute and complete one specific execution, which is basically decreasing the 2 units that you have to multiply to define the cost for that invocation. So there is definitely a clear cost benefit there in just deciding to use Rust for Lambda functions. So that's definitely an element to bring to the table when you think about why using Rust for Lambda. There are other elements and we can talk about them, but the experience in itself, I think, is generally pretty good, with an asterisk, I guess. The main thing is that for any other, well, for the most common programming languages, like if you take Python, if you take JavaScript, if you take Java, the way that AWS gives you an infrastructure where you can write and run code is just create a Lambda. You can even do that from the web console, type some code as a function. Effectively, you receive an input, you do something, and you produce an output. You just click publish, and that's your Lambda function right there. This is because they create what they call managed runtime. So they try to support the most common programming languages and give you a nice experience to do that. Now, in the case of Rust, it's a little bit trickier than that because being a compiled language, there is that compilation step that needs to happen somewhere. So the way that AWS decided to package, let's say, support for Rust is by giving you, rather than giving you an existing runtime and you just attach your own code to it, they give you a library, and that library contains all the runtime that you need. And then by using the library, you just provide your own custom code. You compile everything into one single binary, and then you can ship that as a custom runtime, which seems like a lot of work, and it could be a lot of work, except that AWS spent a lot of time creating a project called Cargo Lambda, which tries to automate all the, I guess, boring part of that project. So for instance, scaffolding a new project, pulling the right library, giving you all the correct structure on how to use that library. If you use this tool called Cargo Lambda, which is effectively an extension of Cargo, you can just say Cargo Lambda init, a new Lambda for this particular type of event, and you get everything ready, and you can just write your own custom code. Cargo Lambda can also build, and can even build for ARM targets, which is another way to decrease cost a little bit, because for the majority of the regions in AWS, ARM costs less than x86. So you can also use the same tool to make sure, regardless of your current architecture, that you are building for the correct target for ARM, and then publish it to AWS. So I will say that the experience overall is quite good. You just need to understand what is the difference between managed runtimes and custom runtimes, and then use the right tooling to remove, let's say, all the boilerplate work and just focus on your own code.
Yeah, which I guess is not a problem that's unique to Rust, right? You have it for any compiled language, fundamentally, that it's not interpreted at runtime. Like you gotta ship something. And I think the choice that AWS made also makes sense, because even though Rust is compiled, you may have dependencies on like system libraries and other things. And so when you package it, Cargo Lambda, if I remember correctly, also make sure to, bundle whatever you need. And famously OpenSSL, if that's something you use. There are other things that might be C dependencies. Although like the number of C dependencies in Rust projects is steadily growing down over time, which is quite sweet from like a build ergonomics point of view. Let's talk about pricing for a second, right? So you mentioned that it's obviously a function of time and the memory that you allocate. And so Rust usually uses less memory than other programming languages or applications within other programming languages, which is good. Time is in what unit? Milliseconds, if I remember correctly, AWS Lambda. But that is time spent in the application, right? Not necessarily time spent doing computations. And the angle I'm coming from is if you're doing something that is CPU heavy, like you're going to spend most of your time obviously in your code crunching whatever you're going to crunch. Like for example, if you have a Lambda function that's processing log data, something I've written in the past, and you're like, okay, I get a JSON blob from an SQS queue, I'm going to do some stuff, and then I'm going to push it, for example, to S3, to a data lake, whatever I want to do. But the other use case, which is slightly trickier, is when your Lambda function is calling some other service, and then it's waiting for that service to return. All the time that is spent waiting on I/O is still time that's built for that Lambda function. And so Rust there incurs the same time. Like the language matters to an extent depending on how much the I/O dominates like the overall runtime. So I think that's one element to look out for. which some different serverless platforms are actually starting to tackle. I don't remember if it was Cloudflare Workers or something similar, where the time spent in I/O is actually not time billed for the execution of that serverless function, which obviously completely changes like what you can build on some of those.
I was not aware of that. That's a really interesting model. I suppose that they are able to do that because they use a different execution model where maybe they,
Right.
yeah.
Because it allows them to pose. Well, I'm a little bit spitballing, but I think what's happening here is that since they use WebAssembly as their compilation target, WebAssembly is a virtual machine. So it just interprets, executes bytecode and runtime. And at any point in time, you can just pose the virtual machine, right? Like you save the state, you start doing something else, and then you resume it. And so since every access outside to the outside world, basically from a WebAssembly module, is mediated by the virtual machine, you kind of know when something is, making a request and waiting for that request response to come back. And at that point in time, you can basically, I assume, pose the virtual machine and just ask to be woken up when data is coming through, which then allows Cloudflare to just use the same compute to probably serve some other serverless execution up until the point when you receive the data back, and then it just resumes your stuff.
Mm-hmm.
And so they're billing you for the time they actually spend executing your code, which is quite sweet. And that's something you can easily replicate outside, I guess, of that kind of world. You can also do some funky stuff, like you can migrate WASM modules from one machine to another machine because they're a VM, and there's a lot of interesting things. If you are a cloud provider that are quite attractive from like the WebAssembly deployment target. As a user, unless you get this kind of pricing stuff, I don't see necessarily the advantage of deploying a WASM module built from Rust code rather than deploying a Rust binary. Rust binary usually going to be faster. But if there is innovation in the cloud space that makes it so that you actually get some interesting pricing models that are not available otherwise, that might get sexier over time. But we'll see.
Yeah.
I want to go back to one of the things you mentioned at the beginning, which is that Rust plus serverless is kind of a sweet spot for Rust. And the angle I'm coming from is I work as a consultant, so I speak to a lot of folks who are evaluating, adopting, thinking about using Rust in some way, shape, or form. And a lot of them are obviously a little bit scared to commit to a Rust project for some of the reasons we touched upon, right? There's the learning curve, then there's, some hiding concerns, perceived technology risk, and so on and so forth. Is Lambda or, serverless in general, perhaps a way to reduce some of those concerns?
I would say probably yes. And the main reason being that generally when you write a Lambda is a much more constrained use case. You are generally writing what you mentioned, glue code. I think it's actually a fair definition. So generally you're writing some kind of integration code between two systems, or maybe if you're writing an API, you're writing maybe the code for one endpoint and not necessarily an entire web application. So generally speaking, by reducing the surface, you might make more acceptable for a company to take a little bit of risk, because the worst that can happen is you're not happy with whatever the language, the adoption, people learning it, the cost or the risk, whatever it is. It's relatively inexpensive to say, okay, I'm just going to rewrite it again in something like Python, because generally it's a few hundred lines of code. It's not going to be thousands of millions of lines of code. So I will say that, again, it's a good first candidate to introduce Rust in a company. Especially could be even better if you realize, like the case that I had in one of the previous company I was mentioning before, well, we have this one Lambda that is particularly becoming either expensive or a bottleneck. Maybe we can invest in rewriting this one in something like Rust. We get lots of benefit and the risk is pretty limited. So I will say that there are interesting trade-offs when it comes to the scope of a Lambda.
Yeah, also because if you try to do the same in a server's full, API, then you usually, if you want to write just that one bit, you have two options, right? You spin it out in a separate microservice. If that one bit happens to be like a vertical slice, but then a variety of things might need to happen for that to be possible, or you need to start to do language to language interoperability. So you might have to do some FFI layer, some kind of how do I get Rust to talk to the host language. And sometimes that is easy. You have a bunch of Python, you want to add a bunch of Rust, easy enough. You have C#, you want to add a bunch of Rust, fairly complicated. Same applies to Java. You start messing around with the JNI. Like, it's not like immediately the bar goes from very easy to very difficult. And obviously, if you're getting started, a mixed language project is probably like a pit of failure, or at least like you're significantly making things more complicated for you. And that obviously goes against trying something with low risk. While in Lambda, since it's islands of code connected by infra, it's much easier to just pick an island and I'm going to do that.
Yeah, and I think another important difference there is that from a team dynamics perspective, you can probably do that Lambda change alone or maybe with your own team without having to interact much with other teams if you have already ownership of that particular Lambda. While in a more serverful approach, that requires probably a lot more interaction across teams, a lot more buy-in from different teams into we actually want to do this, which might make that particular project more complicated or easier for that project to just be dismissed as we're not going to do this, we're going to be okay with whatever else is the problem that made you think about Rust in the first place.
Yeah. If I want to make an extreme example of that, that's kind of the conversation we're currently seeing in Rust for the Linux kernel.
Mm-hmm.
Where people are like, we're just going to add Rust in some modules because these modules are going to benefit from it, primarily drivers. And then other folks are like, yes, but as soon as you have like 10 lines of code of Rust and they are mandatory to build the kernel. So, if you want to build the kernel, you must have Rust installed, the toolchain must be configured, that suddenly the complexity of developing for this project goes up, regardless of the fact that I am developing a module that has zero Rust. Even if I'm working on the other side of the project, now Rust is a concern for me. Even if I'm not seeing it, I'm not touching it, just that build tooling, just like the infrastructure gets more complicated. And then, takes many more months to convince people that you want to do it.
Yeah, there needs to be such a huge benefit that dismisses every other, opposition in that conversation.
And also there's inertia. Like sometimes the benefits might be compelling if this was, a greenfield project, but then existing projects have inertia, other priorities, backlogs, and the benefit needs to be really tall for that to like amass enough activation energy to kind of get the system out of its current steady state to somewhere else. And that applies to kind of any technical change, regardless of, the programming language specifically. Now, a few questions, in closing. There's probably a few people the people listening to this podcast who are building some serverless systems or are considering serverless as a choice for their applications. If they're interested in Rust specifically, are there any specific tips or suggestions you would give them?
Yeah, so I think a good starting point is once you install Cargo Lambda, just go and check the repo and check the example folder. There are so many different examples with some of the most common things you will be building with serverless in AWS, like, I don't know, an API, getting data from a queue, getting data from an SNS or event bridge. And these are the most common patterns that you see when you write Lambdas, and you have examples there on how to do the same thing in Rust. Then there are a few things that are always a little bit tricky. In Lambda, you have this concept of there is like an init phase where you can initialize, for instance, clients, connection to databases, and then you have your actual handler, which might be executed multiple times, depending on the lifetime of the instance that was created to handle executions. So the init phase is generally like when you bootstrap a new instance of that Lambda, occurs only once. And then your handler code can be invoked multiple times if you have multiple events coming in a short amount of time. That creates a little bit of complexity in a way, because in Rust, you need to make sure that whatever you initialize then is correctly injected in the handler. And the handler is also async. So you need to learn about async. You need to learn about how to share things from like an outer scope into the handler. And I've seen people using a bunch of different techniques for this. So that's something that maybe if you check some example and you look for more realistic use cases of Lambdas where maybe you need to initialize a client from the AWS SDK to connect to DynamoDB, for instance. You probably want to do that outside in the init phase rather than doing it for every single request in the handler. So that creates a little bit of friction, especially if you're not proficient in Rust and you bump into the usual borrow checker issues that try to prevent you from misusing the memory. I actually have an example that I built recently. It's a Lambda published open source that implements like an OIDC custom authorizer for API Gateway, where I ended up using the box leak way of sharing memory, which I don't know if it's the best one, but I think in the context of Lambda is relatively okay, because even if you're leaking that memory, you are doing it only in the init phase, and it does exactly what you want, which is just make sure that this particular instance lives as much as the duration of the program. So when the entire instance is brought down, then the memory is going to be cleaned up. You're not really having a memory leak because you do that only once to create kind of a static instance that is available for the duration of the program. So that's one way, but I've seen people using all sorts of other approaches, and that can be another, I guess, one of those challenges that you bump into when you start to do something a little bit more serious that requires thinking about how do you start the memory, how do you share objects, how do you do testing as well. So yeah, just looking into examples or talking with people might be one way to figure out what are the common solutions to this kind of problems.
I mean, the silver lining is that once you understand that, like, the same pattern kind of applies to all type of programs, because most programs have like a bootstrap phase. Most long-running programs like servers, for example, like if you're doing a serverful API, you always have the concept of, I have an application state which I build at the beginning, and then I have a bunch of request scope data that gets built every time a request comes in. And most of the techniques are very much the same, right? You can box leak, you can put stuff in statics, lazy statics, you can wrap stuff in arcs to be able to share them, mutexes, and so on and so forth. Box leaks, I think, are perfectly fine in a Lambda environment because it doesn't make any difference. Like the stuff is going to stay in memory regardless until the end of the program. The only thing that they make slightly more complicated probably is testing, because then all your functions expect something with a static lifetime. So then you need to start leaking the objects in tests as well. And since you may have a lot of tests, that may mean a lot of leaked memory until the test runner kind of exits. But in most cases, assume like we're talking about HTTP clients and other stuff that's really small. And unless you have thousands of tests, which is very unlikely because Lambda functions are small, they'll be fine. So looking ahead a little bit of, mid to long-term view, how do you see the future of Rust in the world of serverless and the cloud deployment space in general? Like, do you anticipate any significant advancements or novelty in this area specifically?
I don't know if there will be dramatic changes, because I think that the kind of application that we are talking about when you talk about Lambda and serverless, generally speaking, simple enough, are more like integration code that you could write them in any language. So it's not like you necessarily need a lower level language, unless if you're looking for performance or cost reduction. Or maybe another element is that as a language, Rust gives you more safety. Like, I have personally this experience that when something compiles in Rust, most likely it's more correct than my JavaScript code. So it gives me a little bit more confident to go to production. Of course, I will have to write tests and everything. But generally speaking, Rust makes me feel like if it's compiling, probably most of the things will be correct. While in JavaScript, you're going to have to find lots of issues at runtime. So make sure you write test, do a few iteration loops of that before you can actually be confident that, okay, now I can go to production. So that's maybe an area where I think the more people will discover Rust and the more they will appreciate the advantages it brings to the table, I guess the more adoption we will also see in the serverless ecosystem. One thing that I find particularly interesting, and this is maybe a design decision of the Lambda runtime for Rust, is that the way that you write an handler function is effectively by providing something that implements the Tokyo service trait. And it's something that not many people uses. I mean, not many people have used in interesting ways yet. But one of the things that I've done in the JavaScript ecosystem is creating this framework called MIDI, which is effectively a middleware framework for Lambdas written in Node.js. And the reason why I think the middleware framework is particularly useful in the context of Lambda is because it allows you to remove all these common concerns like deserialization, serialization, validation, authentication, authorization from your actual core logic. So inside your handler, you can literally just write the core work that needs to happen and then shift all these concerns outside your handler and just attach them as middlewares, which makes your Lambda much easier to read, easier to test. And then all these concerns are standalone units that you can make configurable, you can test independently, and you can share across multiple Lambdas. Now, in Rust, you don't need to have a framework like MIDI because you can just use the Tokyo service and all the middlewares that exist there, which I think is a very powerful thing that exists, but not many people have discovered yet. So maybe I see collections of middlewares that are built specifically for Lambdas appearing in the ecosystem, and people will be able to use them very easily by just attaching them to the instance that you have, that particular service, which is your Lambda handler.
We're talking about Tower service though, right?
You're right, Tower, yes, which is part of Tokyo, right?
As a project, yes, but as separate crate. But yeah, that is true. Like you can share a lot of code you would normally write as a middleware for a serverful application as middleware for like a Lambda application. Although a few things are usually different between the two environments.
Mm-hmm.
Some contextual switching that needs to happen. Cool. Well, I think this is a closing. Thanks a lot, Luciano, for coming over and sharing your expertise about serverless and your experience learning Rust. I'm sure many among the people listening might have learned something. I certainly did. It was a great pleasure to have you.
Thank you so much for having me. It was lots of fun. And yeah, I hope it was interesting for people.
Amazing.